Learn like a pro.
You ever wonder how something as simple as a magnifying glass actually works? Or how a camera lens can capture a perfect image? Well, it all boils down to a pretty simple set of rules. In this explainer, we are going to build, from the ground up, a complete blueprint for understanding exactly how light behaves when it passes through a converging lens. By the time we're done, you'll be able to trace the path of light like an absolute pro. So here's our game plan. We'll start with the basic parts of our lens blueprint. Then we'll get into the 2 golden rules that dictate everything. After that, we'll explore the different kinds of images a lens can make, the secret behind magnification, and a really cool idea called the principle of reversibility. And to wrap it all up, we'll finish with a handy cheat sheet that puts it all together.
Okay, so you can't build anything without a solid foundation, right? So before we can even think about tracing a single ray of light, we've got to understand the basic anatomy of our lens. Let's break down the key parts of our blueprint. First up, we have the principal axis. The easiest way to think about this is like the main center line of our entire diagram. It's a perfectly straight horizontal line that cuts right through the middle of the lens, and pretty much everything else is measured from here. And right at the very heart of the lens, sitting directly on that principal axis, is the optical center. You can think of this as our point 0. It's the central reference point for every single one of our measurements, and it's a super important landmark for tracing light. All right, now for a really, really crucial concept, the principal focus, or as you'll often hear it called, the focal point. This is where all the magic happens. It's the one specific point where parallel rays of light all come together, where they converge after they pass through the lens. This single point tells you just how powerful the lens is. And that leads us to the focal length. We use a lowercase f for this, and it's simply the distance from that optical center to the principal focus. This one measurement, it tells you everything you need to know about the lens's focusing power. See, a shorter focal length means you've got a much more powerful lens, one that bends light a whole lot more. Okay, our foundation is set. We know the parts. Now it's time for the rules of construction. These are the 2 non-negotiable, unbreakable laws that tell us exactly how light travels through our lens. Get these down, and you've unlocked the key to drawing perfect ray diagrams. All right, here they are, our 2 golden rules. Rule number 1 is the center ray. Any ray of light that passes right through the optical center just keeps going in a perfectly straight line. It doesn't bend at all. Simple as that. Rule number 2 is the focal ray. Any ray that starts out traveling parallel to our principal axis will get bent by the lens, and it will always pass directly through the focal point on the other side. Now, here is the big payoff. Where those 2 rays, the center ray and the focal ray, cross paths, that's where the top of our image is formed. This isn't a guess, it's not an estimate, it is a geometric certainty. That single point of intersection tells us everything: the image's exact location, how big it is, and whether it's right side up or upside down. So now that we have our rules, our construction tools, we can start to see what we can build. Turns out there are 2 fundamentally different kinds of images a converging lens can create, and it all comes down to where you put the object. So let's dive into the world of real versus virtual images. You know, the difference between real and virtual images is actually pretty straightforward. A real image is formed where light rays physically actually meet up. You can project it onto a screen. Think of a movie projector, a camera sensor, or even the retina in the back of your eye. A virtual image, on the other hand, is more of an optical illusion. The light rays don't actually meet, they just look like they're coming from a single point. You can see it, but you can't capture it on a screen. And this slide just shows that perfectly. Over on the left, you can see those solid red lines physically crossing to form a real, and in this case, inverted image. Now look at the right. The real light rays are actually spreading apart after the lens. Our brain is what traces them backward along those dotted lines to create the illusion of a larger virtual image. Okay, let's zoom in on one of the coolest and most common uses for a converging lens, the magnifying glass. This incredible effect only happens when we cross one very specific boundary. So what do you think happens when we take our object and we slide it inside the focal length? What changes when the object's distance from the lens is actually less than f? This right here is the focal threshold. The second that object crosses the focal point, the entire game changes. The light rays coming out of the lens don't converge anymore. Now they diverge, they spread out. And so our brain does this amazing thing. It traces those spreading rays backwards to an imaginary point behind the lens, creating that big, upright, virtual image we see when we look through a magnifying glass. Now, before we wrap this up, I want to touch on one more really elegant idea that just shows the beautiful logic of optics. It's called the principle of reversibility. To put it simply, light paths are two-way streets. That's all it means. If a ray of light can get from an object at point A to an image at point B, you can be absolutely sure that it can travel that exact same path in reverse, from B right back to A. It's a really fundamental symmetrical part of how optics works. Whew, okay, we have covered a lot of ground. So let's pull it all together into one final cheat sheet that sums up everything we've just built. Here you go, the 4 key actions to always remember. First, converge. A converging lens always bends parallel light rays to a single focal point. Second, map it. Use those 2 golden rules we talked about to trace the light and find where the image forms. Third, identify. Figure out if the image is real or virtual based on where it is. And finally, magnify. If you want that magnifying glass effect, just move the object inside the focal length. And there you have it, the complete blueprint for how converging lenses shape our world. From the camera in your phone to the glasses on your face, these exact same principles are at play all around us every single day. So now that you have the blueprint of light, what new things will you see?